Hi there everyone, welcome back to my series of short scripting tutorials for Arma Reforger. In this tutorial we will be taking a step away from AI for a moment to look at creating a system for random item population in storage containers. Think of it as a mechanism for random loot spawns for survival style game modes. While I was investigating how to accomplish this in Reforger, I happened upon a mechanism that they used for their arsenal supply boxes, and felt that we could modify the functionality relatively easily for what we want to accomplish. Additionally, I figured out that this was a good teaching moment to cover a couple of object-oriented principles as they relate to Reforger, namely inheritance and overriding existing classes, also known as modding classes. I'm not going to bore you with the technical definitions for these principles, but I will demonstrate their usage in the solution. Now, obviously, the solution is one way of accomplishing this task, but there are a few other ways we could have tackled this problem. I will discuss these approaches later in the video. First, we're going to create our folder structure to store the script files. So for that, we will go to our scripts game folder. In here, we'll create a new folder called components. And inside of this folder, we're going to create a new folder called arsenal. Inside of this folder, we're going to create two script files specifically, one called scr_rs_random create storage and we will create an additional file called scr_rs_arsenal item. With both of these script files created, we'll open them up and get ready to start coding. First topic we're going to cover today is inheritance, as we're going to be using it for our scr_rs random crate storage script. The first thing we're going to do is generate our base class. So to do that, we're just going to create ourselves a class called scr_rs random crate storage component. In addition to this, we're going to create ourselves a component class, which is simply class scr_rs random crate storage component class, and this is the full implementation of that class, minus the inherited properties. The next thing we're going to do is use our nifty little search feature. We're going to change the search scope from, I believe it defaults to current document. You're going to change that from current document to entire solution. And what we're looking for in this particular case is scr_arsenal component. We'll just go find all. We should get our scr arsenal component here. And here you can see there's the component class and the base component. What we're going to do is just grab these class names for use in inheritance, and we're going to pull them over to our script file and just ensure that we are correctly inheriting from them. To do inheritance, you can see here in this class, it's separated by a colon. Some people like to include spaces in the colon separation. Usually I don't. It's personal preference. It will not change how it functions. Right, so there's nothing more we need to do for the component class, but we do need to adjust our base class, our scr_rs random crate storage components. And what we're going to do is we're going to grab two methods from the class we're inheriting from, and those two methods are get filtered arsenal items. So this method over here, and on item removed, which should be down here somewhere. There it is. Perfect. Okay. Now what we're going to do is add the override keyword to these two classes, just to let the compiler know that we are overriding the base version of these classes for our class. So with the basic outline for what we want to accomplish achieved, we'll need to do a little bit of scaffolding to fill in the functionality we need in the overridden classes. So for this class, what we're going to do is we're going to add some comments for our scaffolding. First comment we're going to add is that we want to check here if we're allowed to spawn this item. If not, continue. Then, if we're allowed to spawn this item, then we want to pick a random number of this item to spawn. Cool. And then in our onItemRemove class, we want to tell this thing over here that we don't want anything to happen on item removal, as this is not going to be a self-resupplying box. Okay, so what this essentially means is that so the base arsenal component resupplies or restocks the supply box whenever you pull something out of it. Obviously, we don't want that to happen. So actually, as a matter of fact, because this is such a simple change, I'm just going to do it right now. We're going to yank that out, and we're just going to put return in here. So basically what's going to happen is anything that calls this class is immediately going to return without anything happening. Obviously, if we want to put in our own custom onItemRemove code, we can come add it here, or we can come add it here. But for now, all this simply needs to do is return. Right, then we just need to mention what additional methods we might need to accomplish the functionality we want from the filtration mechanism. So we will add a method. So we need a method here to evaluate whether or not an item can be spawned. So this will be some method called like item can be spawned or can spawn item or something like that. We'll figure out exactly how we want to what we want to call the method a little bit later. And then lastly, we'll need a method to determine how many items to spawn. Okay, so this is the base functionality of our random crate storage. We'll come fill in what we want to do here in a little bit, but first we need to make some changes to our arsenal item class. What we're going to be doing here is creating a modded class. And effectively what a modded class is, it's a base class that exists in Reforger already. However, we want to change the functionality of that class. So one way to do that would be to inherit from that class and just replace the existing functionality with our own new functionality. But because of the way this item is structured, it makes it quite difficult to do that. And you'll see what I mean a little bit later. So what we're going to do is use our our text search, once again, our search function, and we're going to search for scr_arsenal item. And then once we've found all, we'll go to the actual file, which is scr_arsenal item. And then we'll just take the whole thing and copy it over into our class here. So we don't need any of this stuff here. We're not going to be fiddling with the default functionality, so we're just going to remove that there. And then we need to add the modded keyword to the class, just to ensure that that the compiler knows exactly what we're trying to do, that it's not trying to read two the same class names. Then we'll just quickly scaffold out what we need from this. So we'll need a variable and a getter for that variable to control the spawn chance of this item. So essentially this will be a percentage for how likely it is for this item to spawn. And then we'll need a variable and a getter for that variable to control the max number of items that can be created. Now that we've scaffolded out exactly what we want to do, we'll fill in the code for this scr_arsenal item class. So the first variable will be of type float. We'll make it protected, so it'll be a protected float. And this will be m, so because it's a member variable, item chance to spawn. Okay, now this variable is going to take an attribute, and the reason it's going to take an attribute is because we want this to be enterable from where this item is invoked from. So it becomes in the Reforger interface, it becomes an editable item, and it's editable based on how we supplied the attribute. So you'll see what I mean in a second. But we'll give it an attribute. We'll say the default value is 25, as in 25% chance for something to spawn. We'll tell it that we want this to be a UI widget slider. So this is for the UI widget that we're going to be interacting with, it is a slider. We'll give it the name for that UI widget. So in this case, it'll be chance to spawn. And we'll add some basic parameters for the slider. So 0, 100, and 1. So that's lowest value 0, max value 100, and this last number, I believe, is the numbers it increments in, or the steps it increments in. The next thing we're going to add is a protected integer. So protected int, and this protected integer is m item max count. So that's just the maximum number of items that will be spawned. So maybe max spawn count is a more appropriate name there. Okay, and then just much like the first variable we created, we're going to add an attribute. And this attribute will take default value of 1, so just one item to spawn. We're going to give it UI widgets dot slider. We'll call this max number to spawn. And we'll give it some default values. So in this case, I'll say 1, 25, and 1. So base value is 1. So minimum amount of numbers or the minimum number of things that can be spawned is 1. Maximum number is 25. Obviously, you can change these as they fit your need, but 25 is like a really high end on a number of things to spawn in a crate, really. And then what we'll need to do is create the getters for these variables, but those are dead simple. So we'll do the float first. So float get item chance to spawn, and all this thing does is return our member variable item chance to spawn, and the other getter will be int get item max spawn. Pretty much identically, we'll return the m item max spawn. Oh. Perfect. Okay, and that's pretty much everything we need to do to this this class. It is complete. So we'll hop back to our SCR-RS random crate storage class, and we'll start filling in exactly what we want to accomplish here. So we'll, much like before, we'll go through our scaffolded comments. I think it'll be easiest to do the methods first, as the methods are effectively what we will use in the get filtered arsenal items method to return a random number of items, or return the random item list effectively. So first method we're going to add is a protected pool called can spawn item, and this thing is going to take an SCR arsenal item called item to spawn. And what we're going to do here is create ourselves a seed percentage, which will be a type float. So float seed percentage. And that will invoke math.randomFloat with our absolute lowest number being 0.001 to the number of 100. So we could make this 0, but we don't want to make it 0 because you don't want this thing to actually invoke if the percentage chance is 0. Because if something's chance to spawn is 0, it should not spawn. Right, and then we'll simply return our Boolean comparison and that comparison will be item to spawn dot get item chance to spawn is bigger than or equal to our seed percentage. So basically what this is saying is generate us a random seed percentage, and that could be any value from 0.001 all the way up to 100. And if the item's chance to spawn is higher or equal to this value, the seed percentage that's created, then it will spawn that item. Otherwise, it won't. And then we're going to move on to our other method, and this thing is also quite simple. It's going to be a protected integer called get number to spawn. This thing's also going to take an arsenal item, also called item to spawn. And then our number to spawn will be int num to spawn is equal to math.randomInt. So again, utilizing our random, where the minimum number is 1 and the maximum number is item.getCount. Or it's item to spawn, sorry, dot get item chance to spawn. No, get item max spawn count. There we go. It's the method we created earlier. And then we will return our number to spawn. Right. With these two methods having been created, we can now effectively utilize them in our main get filtered arsenal items method. So the first thing we're going to want to do is ensure that we don't set this variable first. And the reason we don't want to set this variable first is because if we do that, it will immediately fill this array with the filtered items, and we want to interact with this array before it gets returned. So what we do instead here is we rename this variable, so temp filtered arsenal items, and we'll make it of type array scr arsenal item. So now this thing loads into a localized variable called temp filtered arsenal items, faction.get filtered arsenal items. Then what we'll do is we'll start up a for each loop. So this is for each item, some item in an array. So we'll do scr underscore arsenal item, item inside of the temp filtered arsenal items array. Then what we're going to do is just brace our comments inside of this for each loop. Right, then what we'll want to do is check if this item is allowed to spawn. So what we'll say is if not, can spawn item, which is a localized member variable. And we'll give it the item because that is what it wants. So if it's not allowed to spawn it, continue. So what the continue keyword does is it tells the for each loop that we're done inside. Please start your iteration again. So it just says ignore this current iteration. Don't go any further. Start your next iteration. Move on to the next item in the array. Then what we'll do is we'll create ourselves a for loop, and inside of that for loop, we'll add int I is equal to 1, I is smaller than or equal to get number to spawn, giving it the item as well. I plus. And then we will insert the item into our filtered arsenal items for the number of times it should spawn. So if this should only iterate once, in other words, the get number item to spawn is only 1, then it will simply insert the item and finish up with the first item in this temporary array. But if there's more in this get number to spawn, what will happen is it'll iterate until it is greater than that value. In other words, iterate until it reaches that randomized value that we created. And then we'll leave the return as it was before. Because this is an output variable, we don't need to return it itself. It'll just come back out of this array with our now inserted items. Okay, so that covers the scripting functionality required. I'll take a moment to talk about the object-oriented principles we just covered. The video should be timestamped, so those familiar with object-oriented programming are welcome to skip ahead to the implementation of the functionality. So, to start with, what we've done with our SCR random crate storage file is effectively used inheritance to build up the functionality inside of this class. The principle of inheritance is relatively simple. When you inherit from a class, you absorb all of its functionality, its variables, methods, and so on, as long as they're not marked with the keyword private. What's more is that you can override this functionality using the override keyword. As you can see, we've done that with the getFilteredArsenalItems method and the onItemRemoved method. When this class is invoked for that method, it will replace the base class's functionality with its own functionality. If no override class is specified for that functionality, it then reverts to the functionality within the base class. So essentially, you can inherit from an existing class and just change one or two things for your new class without too greatly impacting the overall functionality of what you're trying to do. So in this case, it's quite simple. We only overrode two methods. And the reason we only overrode two methods is because we only needed to. Obviously, if you need to do more, you can do more. But at that point, you should start thinking about whether or not it's better to create a new class or to look at some form of polymorphism with a base class and some extrapolated child classes, effectively. So the second principle we covered, which was in our SCR-RS arsenal item, is called class modding. So, or class overriding, however you want to say it. It uses the modded keyword so we can use class modding. So you might want to know why we did this instead of simply creating a child class. And the reason is quite straightforward. We wanted to be able to leave the existing arsenal functionality or arsenal item functionality in place while implementing our own functionality and be able to use both of them within the same mechanism. So the reason we do that is because mostly it saves us time, and that it means that the implementation of our random supply box is much simpler to those who have already constructed their arsenal supply in the same manner that the developers have done it. The best way to explain that you'll see in a second. Once we move over to the implementation, you'll understand why I did it in this way instead of just simply creating a new child class. So with that being said, let's move on to the implementation of this functionality. So for those who followed along from the first tutorial, you're going to want to head over to our previously created world and open it up. And those who are starting this tutorial without having seen the other ones, you're going to want to create a new world and do the basic manager setup just so that you can spawn in and interact with the stuff we're about to place. For those who don't know how to do that, I do explain how to do that in the first tutorial, so you can pop back there and then come join this tutorial again once you've gone over that. So if we head down to our world and we just open it up quickly. Okay, perfect, it's open. So what we're going to do is go to our resource browser and take a search for ammo box arsenal equipment _US. So we're going to go over to this item in our resource browser. Just expand that a little bit. Right click on it, and what we're going to do is duplicate that to RS scripting tutorial. When we duplicate a file, it's going to pop up a little box asking us to name the new file, and we're simply going to replace this with random instead of equipment. So what that'll do is that'll create a new arsenal ammo box, and in our scripting tutorial we'll see it here. It doesn't have that little lock symbol on it anymore, and that's because it's now part of our mod. It's no longer read-only. With this new box created, we can then go and place one down. So what I'm going to do quickly is just head over to where all of our managers and spawners and stuff are. Over here, and I'm just going to place one on the ground for us quickly. Okay, so with one placed, the first thing we're going to do is we're going to open up this, the object properties on the top right. We're going to go to the SCR arsenal component and we're just going to disable it. The reason we're disabling it is because we have replaced it with our SCR RS random storage crate or random crate storage component that we created now. So having disabled that, we're going to go and add a new component. If we just do a strrs search, we'll see that we have our strrs random crate storage component. We'll add that up, and then you'll see it becomes enabled immediately, but everything is unchecked. So for now, we're just going to check everything just to make the largest pool possible for items to spawn. And then we're simply going to say apply to prefab. So what this thing will do is it'll pop open a box of choose one of the inherited prefabs. So obviously we're just going to use our most recent prefab that we edited. If we try to set one of these other ones, it'll tell us we cannot apply to the prefab because it is read-only. So if we select this one, it'll apply it to the prefab, and our prefab will now be saved with this setup. And if we take this prefab from our resource browser and we drag another one in, we'll see that it already remembers that the arsenal component is disabled and our random storage crate stuff is marked full. And then what we're going to do is head over to our faction manager so I can show you why we edited the arsenal item and created a modern class for it. If we go over to our faction manager, you'll see that it is currently set up for 2 factions, and that's because this is the prefab for the US cross USSR faction manager. So if we open our US faction, we'll see under there that there is a sub-menu called Arsenal Configuration. And what this thing is it contains an array of arsenal items. So if we go to anything here, let's find a magazine, for example. So the M16 Stanag, you can see that our item chance to spawn and our item max spawn count have been added as variables here. And you can see that 1 is the absolute minimum value and 25 is the absolute maximum value for this. And the item chance to spawn is 25 based on our default. Obviously, it sets the defaults on every one of these items here. And what we're simply going to do is we're going to edit a couple of these magazines just to make the max spawn count a little bit higher. So we'll go and up these to like 5 possible spawns for the, let's say 5 possible spawns for the box counts. For the M60, we'll do the same thing. Maximum of 5 boxes. So this basically what this maximum spawn count will do is it'll say, okay, somewhere between 1 and 10 magazines will spawn in this particular crate. And similarly for the box one, for these boxes, somewhere between 1 and 5 of these M60 boxes will spawn, and somewhere between 1 and 5 of these M249 boxes will spawn effectively. So, and then of course the item chance to spawn is currently set at 25%, but we could say like for the field dressing, we want a maximum of 25 field dressings, and their chance to spawn must be 100. So every crate must have field dressings in them. And then you can basically what this thing is acting as is a loot table. It'll say, okay, the chance for this item to spawn derives from the faction manager. So having tweaked a few of these values, we're going to go ahead and save this. And then give the scenario a test to see if our random item boxes are working as we expect them to. Okay, so before we start testing, there was an additional thing I had to do here. Once you've applied the changes to your prefab, you need to close the world editor. So in this case, you simply close the world editor and open it again from your world menu. And the reason you have to do that is because it does not automatically apply the changes to the prefab before the closing and opening happens again. I'm not sure why. I suspect maybe it's a Reforger bug, or there's some sort of refresh mechanism you need to invoke in order to ensure that the prefabs are saved correctly. But in this case, the prefab should be working now, so we can place our other 2 crates just to do the testing, and then give it another launch. Right, so let's take a look at our crates. So you can see that we've got a random assortment of items that have spawned. But obviously the bandage is there, as we've set that as 100% for the bandage to see. So let's go take a look at the other crate. And once again, different assortment of items, but same bandage is still there. We're going to have a look at the 3rd crate. Again, different items, but the bandage is definitely still there. So there you have it, random item spawning in crates. Obviously, you can tweak what spawns in these boxes based on the configuration settings you've set up in your loot table. but for obvious reasons, that is up to you and how you want to configure things and how you want the randomization to occur. Before we close off, I just briefly want to talk about other possible implementations of this solution. The reason I mention this is because while our solution is elegant in its usage of existing functionality, it does not cater to every possible usage. For example, if we want to implement this solution in a scenario in which we do not want to use the faction arsenal config to control what is added to those supply boxes, we would then have to retrofit this solution by updating the faction manager to include the faction we want to spawn items for, which isn't ideal. It would unnecessarily bloat the faction manager, especially if we're not going to be using those factions. So the alternate approach to this would be to create a dedicated manager for random storage and then adjust the random storage component to utilize that random storage manager. And it would then load the items instead of the faction manager. Now, this would require more work, but would ultimately solve that issue we spoke about previously. Of course, the downside to that is you would need to manually configure the random storage manager for each item instead of using the built-in functionality that comes with the faction manager. So if the community is building their factions with their own respective faction managers and setting up the arsenal config exactly the same way Bohemia has done it, then this solution would automatically incorporate those items as soon as you include that faction in your faction manager. So the point I'm trying to make is that you need to cater your code to your solution. It helps to sit down and come up with a basic outline of what you'd like to accomplish before you start hacking away at code to make something work. For those who don't have experience in this industry, this step would be called the design phase of your solution. Now, every person is different, so you just need to work out what feels right to you. Ultimately, everything is easier to do when you know what you're trying to accomplish beforehand. Anyway, enough of my rambling. I hope I've covered everything in this tutorial with appropriate depth. If you'd like to follow along without having to type out the code while we're busy, in the description you will find a link to the Git repo with the source code for this tutorial. The branch for this tutorial's code is called Random Supply Tutorial. As before, if you have any further questions, comments, or requests for more tutorials, let me know in the comments. Thank you for watching and happy mission making.